This video will address assembly design methodology. There are two different methodologies that can be used when creating assemblies: bottom-up and top-down. Each of these techniques has their own strengths and weaknesses, but most assemblies can use a combination of each method to accomplish the needed design results. Bottom-up. In the bottom-up method, each part is created separately from the other parts. When the parts are completed, they are inserted into an assembly and constrained together. The constraints that are used include mates, aligns, angles, orients, and tangents. Here's a typical bottom-up assembly building process. Starting with a new assembly file, the parts of the assembly are inserted one at a time and constrained to each other to form the complete assembly. Top-down. In the top-down method, the parts are created or edited from within the assembly. This allows you to create inter-design constraints, parent-child, so when a feature changes in one part, the other parts will also change. When the assembly is saved, each part will be saved as its own individual file. These files are treated as regular parts. They can be opened up separately from the main assembly and edited and inserted into their own 2D drawing. In this example, a new part will be created within a very simple assembly. The base part provides a planar surface to sketch on, as well as geometry to use as a guide for designing this part. We start out by sketching a rectangle on this planar surface. Collinear constraints are applied to each side of the sketched rectangle to line up the edges. These collinear constraints will also ensure that the part being created will automatically update its geometry to remain collinear with the base part if the geometry of the base part is changed. The rectangle is now extruded to be flush with the top surface of the base, and fillets are added to match the base part. Holes are created to match the base part, and a vertical post is created and constrained to an edge on the base with a 1/2-inch dimension. Once the vertical post has been extruded, a horizontal cylindrical section is added as the final feature. The new part is now complete. The original base part is semi-transparent while the new part is being developed. To return to assembly mode, right-click on the assembly name, which is the uppermost item in the Design Explorer, and select Edit Part/Subassembly. To demonstrate the parent-child constraint concept, we'll edit the geometry of the original base part. The 3-inch dimension is now changed to 5 inches. Notice how the newly created part conforms to the changes made to the base part. This video covered assembly design methodology. There are two different methodologies that can be used when creating assemblies: bottom-up and top-down. In the bottom-up method, each part is created separately from the other parts. When the parts are completed, they are inserted into an assembly and constrained together. In the top-down method, the parts are created or edited from within the assembly. This allows you to create parent-child inter-design constraints, so when a feature changes in one part, the other parts will also change.